All right, picking up with 8.4's your turn problem. We were in the middle of part C where we had factored out a GCF and that had left us a binomial, difference, and I see squares. So what I need is roots. So I have a root here with x and a root here of 4. And so now I can form those conjugates. So 2 and an x with a 4 in one binomial and an x with a 4 in the other binomial. And I need 1 to be a plus and 1 to be a minus, and now I'm done factoring it. Now looking at my next problem, again I have another GCF, so I'm going to take that GCF out first. They're both divisible by 2. And when I take the 2 out, 2 comes out of there and leaves me with a 16, and that's x to the 4th. And then minus, and 2 comes out of there. 2 will go into 16 8 times, and 2 will go into 2 1 time. And now I do see again that I have a binomial and a difference, and that's a square and that's a square. So I can say that this is 4x squared this time, because the 4th power, right, 4 divided by 2 is 2. And then the square root of 81 is 9, so then I have the difference, or the roots there. So now I can form my conjugates. So I have 2 times 4x squared plus 9, and then I have my 4x squared minus 9. But this one is one that we don't want to get too jumpy on, because look, that 4x squared minus 9, that's actually the difference of two perfect squares again. So I need the roots here and the root here, and then I'm going to form conjugates again. So here I have 2 times 4x squared plus 9. Remember, the sum of two perfect squares does not factor unless there would be a GCF, which there's not. And then I need a 2x plus 3, and I need a 2x minus 3. And now finally I'm done with that one. But there was quite a bit more factoring to do, so that one had a lot to keep track of, and keep going until we're done. Factor completely. Now when I look at this next one, I go, whoa, that's a trinomial. Trinomials, what should I look for first? I should always look at any trinomial as, is it a perfect square trinomial? Well, that's a square, and 2 times 5 times x does indeed give me 10. So this is a perfect square trinomial. And this is where we do want to remember that trinomials get small, right? Binomials get big, but trinomials get small. I have the root and the root quantity squared, and then whatever's here goes in the middle. So we want to kind of remember that. Now down here I see a binomial again, but look, this time I've got a cube. So I have a cube root 2x and a cube root 4. Oh gosh, look at that. I missed a GCF again. Don't miss your GCFs. Check for GCFs first. Those are the things that we always want to check first. When we go to a factoring problem, the thing that we want to look for, number one, is does it have a GCF? So yes, there's a GCF here. So 8 and then x cubed minus 8, and then we see, oh yeah, it's still got a GCF, right? So we're going to take out, or excuse me, not GCF, but it's still got difference of two perfect squares. So we have the roots there of each of those, and now we can finish off our factoring problem. So we write down our GCF, and then a binomial with those cube roots, and then square the first one, product of the two roots, always plus square of the second one, and then this sign goes in the middle, and the opposite of that one goes in our trinomial. And so there's our roots there. All right, now moving on to the next one. Our I here, we look at I and we say, okay, anything in common? Well, there's actually a 5 in common here, so let's take out 5, and that's going to leave us with 25a cubed minus 8b cubed. And unfortunately, that's not a binomial difference of cubes, because 25 isn't a difference of cubes, so that one's done.